Welcome to the next lesson on our course, where we begin our discussion of key concurrency and scheduler operators in the Flux class and related classes. These operators arrange to run other operators in designated threads and thread pools, and we'll be focusing on the subscribe on and publish on methods from the Flux class, as well as the scheduler's new parallel factor method. The subscribe on method has some interesting semantics. It arranges to run subscribe, unsubscribe, and request on the specified scheduler parameter. This parameter indicates what thread to perform the operations on. It returns a flux that requests asynchronous processing. The semantics of subscribe on are a bit unusual. In particular, placing this operator in a Flux chain impacts the execution context of the on next, on error, and on complete signals. As you can see in this example, which we'll take a look at when we explore the case study in more detail, we first go ahead and create a publisher, which is a new parallel scheduler, which has one thread in it. So it's a thread pool of size 1. And then we go ahead and we iterate from 1 to max iterations, and we call subscribe on that publisher. And what that means here is that the range operator and then all the subsequent operators, map, do finally, subscribe, and so on, will all run in the context of that publisher thread. They'll all run in the background thread. Interestingly enough, we can put the subscribe on method pretty much anywhere in this chain, and we'll have the same semantics and the same effects. So if we put it down right before subscribe, we'll also have all the operations run in that publisher thread in the background. However, if a publish on operator appears later in the chain, then that will then change the thread context where the rest of the operators in the chain below it execute. And note that publish on can appear multiple times, as we'll talk about in a moment when we talk about the publish on operator. RxJava has a subscribe on operator in its observable class that works with the same semantics that Project Reactor's subscribe on method works on in the Flux class. Let's now turn our attention to a companion operator called publish on. This operator arranges to run the on next, on complete, and on error methods on a supplied scheduler param. Once again, this scheduler param indicates what thread to perform the operation in. And it also returns the flux that's requesting the async processing. The semantics of publish on are a bit more straightforward than the semantics of subscribe on. Remember, subscribe on has this characteristic that things actually ahead of the call to subscribe on will be affected by the subscribe on, as well as things that occur below it. In contrast, what publish on does is it influences the threading context where the rest of the operators in the chain below it execute. And again, we'll also take a look at this example later when we get to the case study. But here, we're creating another scheduler, which is going to be the subscriber. And it also is calling the new parallel factor method, which we'll talk about in just a moment. We're going to have, in this case, a thread pool with a size of 1, and then all the operations from publish on down to the end of that chain, or the occurrence of the next publish on, will all run in the context of the subscriber scheduler, or the subscriber thread. Now, what's interesting here is if you put more publish on operators later, you can actually change the thread context again. So just for kicks, I don't necessarily recommend doing it this way, but just for fun, I created a subscriber thread pool with 2 threads in it. And you'll notice that we had the first publish on, which is going to then go ahead and check to see if the number is prime in a different thread from the thread that was actually generating or publishing the numbers in the first place. And then after checking if the number is prime, we're going to rearrange to run on perhaps yet another thread in that thread pool to do the actual printing and processing of the results. Now, again, you can do this with Project Reactor or RxJava for that matter, but I don't really recommend publishing your operators and your data flows in too many threads. You'll start to get too much context switching overhead and too much cache memory overhead and too much memory movement overhead and synchronization overhead and so on and so forth. And it just becomes more trouble than it's worth from a performance point of view. But the point is you can do these things very quickly and easily using the publish on operators as we're showing here. Turns out that RxJava has a method called observe on that's part of its observable class that works the same way that publish on does for the Flux class. Why they came up with 2 different names for doing basically the same thing, remains somewhat of a mystery to me. I guess they just like the term better, publish on, in the context of RxJava, which came, in Project Reactor, which came later. So whatever. Just be aware that they mean the same thing. Observe on and publish on have basically the same semantics. Now let's go ahead and turn our attention to a key scheduler operator that's used by the Flux class. And this is the new parallel factor method that's defined in the scheduler's utility class. And what this factor method returns is a fixed size pool of single-threaded executor service-based workers. And the parameters that are passed in here can be used to give a name to this particular thread pool, and also the number of worker threads you want in the pool, which could be 1, 2, n, whatever you want it to be. What this does is it returns a new scheduler that's suitable for parallel computations that are going to be CPU or computationally intensive. It is not designed to work with blocking operations. And in fact, if you try to use blocking operations, then it will reject them. So it doesn't want to work for things that are blocking, like I/O or network communications and so on. It just wants to work with things that are compute bound. You can use this to create a custom parallel scheduler, as we had done in the previous discussion about subscribe on and publish on. And in fact, this is the example we looked at before, just kind of fleshed out a bit more, which we will also talk about shortly when we get to the case study at the end of this lesson. And this arranges to emit random big integers in the publisher thread. So this particular piece of code is going to generate random big integers in the publisher thread. And the way it does that is it uses a subscribe on operator to subscribe on this publisher scheduler, which has a thread pool of size 1. It's very important to note that the scheduler and the thread or threads that are returned from new parallel are not implemented via daemon threads, unlike some other things that we've talked about where they are implemented by daemon threads. As a consequence, the app won't exit until the pool is properly disposed of explicitly. So what you typically do, and we'll talk about this later, again, in the context of the case study and some other things we're going to talk about here shortly about other action operators in the Flux class. What you typically can do is use the do finally method, which is called once when the stream is going away, to go and dispose of the resource, in this case, the scheduler, thereby ensuring that its resources are cleaned up and the thread is shut down, and then the program can exit properly. If you don't do this, then your program will continue to hang even when all the other threads have shut down because it's not implementing this as a daemon thread. Interestingly enough, RxJava's scheduler utility class does not have an equivalent method to new parallel. However, you can use the from method that's part of RxJava's scheduler class in conjunction with the Java executor framework. And in particular, you can use its various types of thread pools. You can use from to connect it with a cache thread pool, a fixed size thread pool, or even a work stealing fork join pool. So there's plenty of flexibility with RxJava. It just doesn't work in quite the same way that you get with Project Reactor for various somewhat mysterious reasons. So that's the end of our first discussion of key concurrency and scheduler operators in the Flux class or used by things in the Flux class. And we'll talk later about some other examples that are helpful to see in other contexts for creating parallel pools.